Off by what is the density of an object with a mass of 52 grams and a volume of 17.5 milliliters. In this case, we do not know the density, and that's kind of what we're looking for each time is what don't we know? We don't know density, but we do know the density formula. It's mass divided by volume. So our mass right here is 52 grams, and we would divide by 17.5 milliliters. And we have grams on the top, milliliters on the bottom, and those units are going to carry over into our answer. 52 divided by 17.5 is going to give you 2.97 grams per milliliter. If we were trying to figure out if this object floats or sinks, this one would definitely sink. Its density is greater than 1, which is that of water. The next one, it's also asking us for density. And now you've probably noticed this table on the top. We're not going to use the table up on top until we get to number 4. Number 4, we're going to need to figure out the density of iron, so we're going to use that table on the top. So the next one, number 2, what is the density? So again, we don't know the density, but we do know the density formula is mass divided by volume. We have dimensions of a cork, 2 by 2 by 2, and we are given a mass of 5.56 grams. All right, well, 5.56 would be our mass, 5.56 grams. We got to put that on top, and then on the volume, or on the bottom, we would put volume. In this case, we are given dimensions, so we have to first do 2 times 2 times 2. 2 times 2 is 4, times another 2 would be 8, and we did centimeters 3 times, so centimeters cubed is what we're using here. So 8 centimeters cubed is our volume. Okay. And you have grams on the top, centimeters cubed on the bottom. Now those units will carry over into your answer. So a small number, 5.56, divided by a bigger number should be less than 1. And number 2 is, yes, 0.695. Okay, number 3. Number 3 is saying what is the mass? If we don't know the mass, we use the mass formula, which is density times volume. In this case, we're given a density of 3.55 and a volume of 27 milliliters. And so let's plug in the density first. 3.55 grams per milliliter, and that will be multiplied by 27 milliliters. Awesome. Okay, 3.55 times 27, and remember too, we're trying to find a mass here, so our answer is going to be in grams. If you're wondering, look back in the problem, you see the little g there. Our milliliters would cancel out, leaving us with just grams, and in this case, how many grams? 95.85. Awesome. Number 4, here's where we're going to use that chart on the top because it tells us that we need to know the mass of an iron ball with a volume of 2,215 milliliters. All right, so mass equals density times volume. In this case, we don't know our density yet, but if you look up at the chart, find density of iron, it's 7.87. Just going to use grams per milliliter, and we're going to multiply that by 2,215 milliliters. Our milliliters would cancel out. Our units should be in grams here as we're solving for mass. Should have a pretty big number, almost 8 times 2,000. 17,432.05. Another way to write it would be 17.4 kilograms. But we just want the grams. All right, next one, number 5. What's the density of a pink golf ball? All right, so if you're a golfer and you know what happens when golf balls go in the water, do not give this one away yet. But you have a golf ball. We need to know what the density is, okay? So density is mass divided by volume. Our mass in this case, it says 7 grams there, and this one says 6.8 milliliters. So put your 7 grams on the top, 6.8 milliliters on the bottom. You have a big number divided by a smaller number, so it should be greater than 1. And yes, 1.03 grams per milliliter would be your answer here. And so we are slightly above 1 there. So slightly above 1. So will it float in water? No. It's going to sink. Why or why not? Well, the density is greater than 1 or less than 1. It is greater than 1, so it's going to sink. That's what we're comparing it to, the density of water. If it's greater than 1, it sinks. If it's less than 1, it floats. How could you make it float? In class, some people said, what happens if you cut it in half? Well, if you cut it in half, we're halving the mass, and you would take half of the volume, so you'd still be in that same ratio, or you'd still have the same density. You could cut it in half and maybe hollow out the inside and put it back together. It might be a little bit of a weaker golf ball and maybe won't travel as far on your drives, but that's a way you could decrease the density. And then one other thing that a student came up with is instead of doing something to the golf ball, do something to the solution or do something to the water. You could add salt to it. What's salt going to do? Well, if you add salt to it, salt is increasing the density of that solution. So if you can have really salty salt water, or even just a little bit, it'll get that density up above 1, because really we're trying to get above 1.03 here. So add a little bit of salt, maybe in a beaker, like if you had something like this and you filled it up with salt water and you put your golf ball in it, then yes, you could probably get it to float. All right, number 7. An object has a mass of 17.5 grams, volume 16.2. What is the density? Okay, don't know the density again, but we know the density formula. It is mass divided by volume, so 17 grams divided by 16.2 milliliters. And that would give you 1.08 grams per milliliter. And now we have some questions here. Will it float in water? Well, if it's greater than 1, it is not going to float in water. Will it float in chloroform? Well, we have to look up at our chart and figure out what the density of chloroform is. It's right here at 1.49. So this density is not greater than 1.49, so it would float in chloroform. Chloroform is more dense. And then mercury. What about mercury? Well, look up here. Mercury is even more dense at 13.55, so it would for sure float in mercury. It'd be even more displaced out of the water. Awesome. Number 8, you've got 3 lead sinkers, or the label on the can reads lead sinkers. So you know what the material is? We have 3 of them, each with a mass of 2.5 grams. We need to know how much water will these 3 sinkers displace. So water displacement is essentially volume. We're trying to figure out the volume in this case of the water that falls out or gets displaced. And so if we are trying to find mass, which we need to figure out volume, it's mass divided by density. We need to find the total mass first. I give you a little hint here, solve for volume after finding the total mass. Well, if one of these sinkers is 2.5 grams and we have 3 of them, just do 2.5 times 3, and you would get 7.5 grams as your total mass. Okay, and then your density. Well, it doesn't tell us any other variables here, but it does tell us that these are lead fishing sinkers. And lead has a density of 11.35. 11.35 grams per milliliter. And do 7.5 divided by 11.35, and you're going to get 0.67. And milliliters, if you kept it in centimeters cubed, that's fine too here. Either or works. Okay, awesome. An object, number 9, with a mass of 13.5 grams and a volume of 5.75 centimeters cubed. What metal is it? Well, if we're trying to identify the metal, we have a chart of densities on the top. We're also given grams and volume, so we know the other thing we don't have is density. So find mass first, 13.5 grams. Put that over your volume, 5.75 centimeters cubed. You have a big number divided by a smaller number, so it should be greater than 1. 13.5 divided by 5.75. 2.34, and then it's trying to figure out what metal this is, and grams per centimeter cubed. So let's look for 2.34 up here. And there it is right here, boron. 2.34 is boron. Awesome. Okay, number 10, two objects, same volume. One has a mass of 2 grams. The other one has a mass of 3 grams. Which one would be denser? All right, so it helps to visualize this one. So let's just say, well, first off, it says two objects with the same volume. So let's make two objects, two boxes with roughly the same volume. Okay, close enough there. One has 2 grams, so let's say that these are grams, 2 grams. The other one has 3 grams. So density is just how much matter is packed into a certain amount of area. Which box has more matter, or more mass packed into that same amount of area? It would be this one, okay? So which one would be denser? The one with 3 grams, okay? The next one, similar concept where you kind of have to visualize it a little bit, or if you can do it the math way too, that works. Or sorry, number 10, I guess you could do density and mass, so 2 divided by 1, or density equals 3 divided by 1. The one with 3 would give you a larger density. And then for number 11, now it says they have the same mass, but one's got a small volume, one's got a large volume. So this time I don't have to draw my boxes the same because one is supposed to be small and one's supposed to have a large volume. Okay, so the volumes are different, but what stays the same? It says the mass. So let's say there are 5 atoms there. 1, 2, 3, 4, 5 atoms in that box. Which box is denser? Well, this one you can see there are 5 atoms packed into a small space. In this one, 5 atoms packed into a larger space. Density is just how much matter can you fit into a certain volume. Well, we have more matter in this volume here, so our density would be greater with the smaller volume. Okay, and last but not least, 2 identical cans have labels that fell off. Oh boy. But they look similar. Your boss tells you he's coming at 1 p.m., and you got to know which one's which. In high school, you took chemistry and you learned about density. Metal A has a mass of 26.25 grams, metal B 34.063 grams. You submerge each object into a graduated cylinder. Metal A moves the line from 8 to 10.5, and metal B moves the line from 16 to 19. What are their densities? Awesome. Okay, so step 1 here, it says determine the volume of each by calculating how much the water level went up, which is water displacement. Okay, so you guys, water displacement is something like you put your graduated cylinder at 70 milliliters here. Make sure it's on a flat surface. Drop your object in. Hopefully it doesn't splash too much. And we went up to 75. So if you started at 70 and you went up to 75, that's going to be a difference of 5. So our volume would be 5 there. In this case, it's telling us that metal A went from 8 to 10.5. So from 8 to 10.5, that is a difference of 2.5 milliliters. Okay, 2.5 milliliters there. 2.5 milliliters. Then the other one goes from 16 to 19. That one's a little easier math. 3 milliliters there. Okay, just how much did it go up by? Next thing says write the density formula and plug in your numbers. So density equals mass divided by volume. And so our mass for A is given up there, 26.25 grams. And we just figured out our volume for this one based on how much the water went up. Our units are going to be in gram per milliliter here. Metal B, you would set it up by going 34.063 grams divided by your volume in this case, which is 3 milliliters. Same thing here, your answer would be in gram per milliliter. So for the first one, 26.25 divided by 2.5, it's going to give you 10.5. And then the other one, metal B, 34 divided by 3 essentially is going to give you 11.35. Okay, now your last step is to compare the densities you calculated with the density table up on top to see which metals they are. So first one we're looking for 10.5. 10.5, where you at? There it is. Okay, silver is 10.5. Okay, then the other one, we're looking for 11.35. 11.35 is lead.